In this video, I'm going to do a walkthrough for the new version 3 pinball, which I sort of originally called the bump and tilt because it has a bump mode and tilt mode, but it made sense to just make it the new version of the pinball. And it combines the original standout design with the original pinball design and allows you to switch between them. So let's go and just investigate how this circuit works. Okay. I'm going to zoom in here on the Eagle file. And here is our input stage. So I've got the signal coming in through here. We've got a current limiting resistor along with a bypass capacitor to block any stray DC charge. This is all about just making the switching as quiet as possible. This will set our input impedance, and higher input impedance will require less, basically less power from your pickups. They don't have to work not quite as hard, and so you can get a little more output from them. You can also oftentimes get a little more sparkle and chime, but it makes the guitar's volume knob a little less interactive because of the high input impedance. So anyway, if you lower the input impedance, you will lose some of that output, usually not a ton, but some. And what you'll notice if you really lower it, you'll start to notice some of that sparkle go away. And that can sometimes be actually a desired effect. But it'll get way more interactive. The lower and lower it goes, way more interactive with the guitar's volume knob. And I'm specifically talking about like passive guitars, not ones that have like active outputs. Okay. And then it goes into this buffer stage. So this stage right here doesn't amplify, doesn't EQ, doesn't do anything. It just buffers it so I can split it a bunch of different ways without, pulling down the pickups. And so after that buffer stage, there is a buffered output. So if you want to use buffered bypass mode, you can use that. But then it splits it, and it splits it 3 ways. So we'll see it here. Okay, one signal is going to go straight through here and go to this switch. And this signal is going to be the dry side of the mid-boost mode. So in the mid-boost mode, when you turn the blend knob down, you get the dry side. And when you turn the blend knob up, you get the EQ mid-boosted side. So that's what this is for. It's going into there. This right here is the high-pass filter. So it's cutting bass response. Okay, so that's going to go here. And then right down here is something that gets switched to come from 2 different places. Okay, so this right here will get switched to come from two different places. One is to come straight from here. If it's in tilt EQ mode, it's going to get it straight from the buffer. And this is our low-pass filter. So if it's in tilt EQ mode, I need my high-pass filter and my low-pass filter to be fed the same signal. And then I cut bass on one, cut treble on the other, and then blend that together to tilt. Something more bassy, something more trebly, right? And so it could be fed directly from the input signal. Or if you want it in mid-boost mode, you want to cut the low end and then cut the high end. And then that leaves that mid-boost. So you run it through your high-pass filter, and then it goes through this switch over here, and then eventually gets sent into, it goes right there and goes into right there through that switch into your low-pass filter. And that's if you're in the mid-boost mode. Okay. Now, a couple of notes here. This right here is, I need to zoom out a little bit. This right here is a gain circuit that is needed in the mid-boost mode, but not needed in the tilt mode. Here's why. So in the tilt mode, I send the same signal through a low pass and high pass, and then eventually blend them together. And when I blend them together, I want those signals to be roughly they're not going to be exactly the same volume, but in that ballpark or whatever. I'm not going to amplify them separately. Okay, but when I do both of them to the same signal, so I first start by cutting lows, and then start by cutting highs, I've greatly reduced the volume, and so I need to make up that volume, and that's what this circuit is for. It's for making it up. So it's only active in the mid-boost mode, and so that's why it says boost down here. Now, it gets a little bit convoluted when it comes to like exactly how that works, but bottom line is that it's going to go down to this circuit right here. This circuit turns on when you turn it into boost mode, shorting that to ground, making this circuit right here amplify. If this is not shorted to ground, then there's no amplification. It's basically a buffer. Well, yeah, because this has nowhere to go. So then you're just in buffer mode. I will get to the switching section last. It's definitely the most convoluted. But after the switching section is this mixing section. So let me zoom in here into our output section. So one of the signals that I've switched in, whether it's dry or the high pass filter, and then the other side, whether it's the whole EQ or just the low pass filter side, gets to these two parts, and then as I turn this knob one way or the other, it gradually decreases. As I turn the knob this way, you can see this ground, it's going to gradually decrease the volume right there. And then if I turn it that way, it'll gradually decrease and therefore increase it on the other side. And so that blending circuit comes here, and the volume output of that blending circuit is set by this potentiometer. And it can have quite a bit of volume output. And then here's our coupling capacitor, our current limiter resistor. Our drop-down resistor is all about keeping any sort of like stray DC voltages out of the output so that you don't get like switching noise and other fun inconsistencies. Okay, so that's the mixing stage, output stage. You can see this in a bunch of other pedals that I make that use a mixing stage. Okay, now about the switching. It requires 3 switches. And the way this is even labeled in the schematic is actually intuitive and then not intuitive. Okay, I'll show you. Okay, first let's talk about the physical switch. So there is a DP-DT on. That means it's got two switches that switch together, you know, in two positions. So here's one of them. And this is actually switching between taking the low pass signal from the buffer, that's tilt mode, or from the high pass filter after this boost stage, that's in our mid boost mode. Okay, so that one's a little easier to understand. Either I get it from there or I get it from there. Okay, but there was a lot more switching than was possible with just a switch that would actually fit in here. And so in comes this switch. There are 4 switches. They're SPST switches. And the way they work is that they're on, off. So they either connect or disconnect based on whether this is high or low. And the way this is labeled is that if the bump pin right here goes high, this turns on. So that this is a switch that turns on when you're in bump mode, you're a standout mode. And then these middle 2 in tilt and this bottom one in bump mode, okay? So this is where it gets a little bit weird, but not too bad. So here, if I switch this switch that way, it shorts out, sends to 0 volts, bump mode, which turns off the bump. You see that? It turns off the bump, meaning it turns on the tilt, meaning that whichever way this switch switches, so if it switches towards the bump, it turns off the bump, turning it on tilt, and if it switches towards the tilt. Anyway, that's the way this part of the circuit works. But what's weird is that when you activate tilt mode, you send this to 0 volts right here. You send this to ground, which turns on this, which is needed for bump mode. This is the switch that turns on the gain circuit. And so when you switch into tilt mode, it turns off the tilt and on the bump, but then it activates this other one that turns on the boost circuit. And this switch isn't existent on the prototype. So when you watch the prototype, when I switch it into from bump to tilt, it makes a pretty loud pop. But then this circuit is in the final version. This will soften that transition. So when it goes from that without that gain boost to that gain boost in the mid boost, it's much quieter. So anyway, so there you go. There's the whole circuit. It's simple in some aspects and convoluted in others. And hopefully that walkthrough was helpful.